Hello everyone and welcome to 12 through 18 on the Chapter 10 quiz review. Here's what the next set of directions say. Solve for the indicated values, round to the nearest tenth if necessary. So if we need to round, we will round to the nearest tenth. All right, let's look at number 12. Number 12, I noticed that I have two chords. I have a chord right here that has the same marks on it, congruence marks, as the chord right here. Okay, and so because that chord is 12, we know that this chord is also going to be 12. And so what do we know if the chords are congruent? Well, we know that the distance to the center is going to be the same, that perpendicular distance right there. So if this is 5 and we have that right angle right there, we know that x is also going to be equal to 5. X is going to be 5. Okay, that was our two chord theorem. All right, let's look at number 13. Number 13, I do have two chords happening. They are not marked as congruent, but I do have that this is 3 and this is 3. That distance to the center is the same. And so if those chords are going to be congruent to each other, because you can kind of look at it, if you were to rotate it and turn it, it would wind up on top of itself. If you were to fold this circle right down the middle like this, those would wind up on top of each other, okay? And so since those 3's are congruent, I get to conclude that the chords themselves are congruent. So if this is 8, we know that this side is going to be 8, so that whole chord is 16. So this entire chord will be 16 as well. So x is 16. Sorry, guys, if you can hear my son yelling in the background. He's supposed to be napping. All right, here we go. We've got a chord here. We've got a chord here. We've got our right angles. We've got this piece, and we've got this piece, okay? And so we know that those two triangles end up being congruent. Here is my hypotenuse. Here we go. Those are overlapping, and so what we can do is we can say that those two pieces are going to be congruent. I can take 5x, and I can set it equal to 3x plus 4, and so we'd end up getting 2x equals 4, and x is going to be equal to 2, because those two amounts are going to be the same. All right, 15. 15, we've got a diameter, and it is cutting off this chord at a 90-degree angle. So we know that it's perpendicular, but it's also going to cut it in half. So I know that I get to add congruence marks both here and here. Not only are those two pieces going to be congruent, so y plus 4 equals 2y plus 1. We end up getting, when I move the y over here, you can move the 1y to the other side, subtract the 1 from both sides, you get y equals 3. How do I know that I did it right? Because 3 plus 4 is 7, and so is 2 times 3 plus 1 is also 7. So those are congruent. They didn't ask me to solve for x, but just in case you did, we know that this piece is going to also be congruent to this piece, okay? And so 3x minus 4 would be equal to 5x minus 18, but they did not ask me to solve for x, so I'm not going to waste my time doing it. Life's too short. All right, number 16. Number 16, I've got another diameter. That whole thing is 18. I've got this little piece is x. It's cut off at a right angle. There's my right angle. And then I also know that this whole thing is 14. So if that whole thing is 14, we're going to work with this little baby right triangle right here. This is, oh goodness, this is a right triangle. So we're going to work with it. I know that this is a right angle. And so what we're going to do is we need the smaller pieces. So what is just this amount from here to here? Well, that's half of the chord, so it's going to be 7. We have our x. We have our x. I'll just highlight that this way. Here's our x. Okay, and then we have our radius, which is this piece right here. 18 is the entire thing, so this piece is going to be 9. And so when I plug that into Pythagorean theorem, what I'm going to do is I'm going to do x squared plus 7 squared is going to be equal to 9 squared. So what you're going to do in your calculator is you're going to do 9 squared minus 7 squared. So 9 squared minus 7 squared. So that is going to give me 32. Boom. X squared equals 32. I'm going to take the square root of both sides. They did tell me to round, so I don't have to put it in simplest radical form. They said to round to the nearest tenth. So this is going to be about 5.7. I always like to check myself before I write myself and to make sure that makes sense as an answer. Is 5.7 shorter than 9 the hypotenuse? It is. Okay. Let's do 17. 17 is very similar, but the only issue is that they have this chord that is, in fact, being, again, let's color code it the same. It is, in fact, being bisected because of that right angle coming out of the center. with that piece of the radius. And the only problem is that they do not have the this closed. We want to close this right triangle. So because this is x, I know that I could copy that to right here. And this will also be x. So I can close in that right triangle. And so now I've got the entire chord is 10, so just this piece that I need is going to be 5. This piece in yellow is 4.2, and I'm going to use Pythagorean theorem to solve for x, because here is my baby right triangle. So I'm going to do, here we have the 4.2. Oh, goodness. Y'all. 4.2 squared plus 5 squared, just trying to color code, equals x squared. So I get to type this whole thing into my calculator. You don't have to break it apart or do it in steps. 4.2 squared plus 5 squared is 42.64. That is what x squared is equal to. So I'm going to take the square root of both sides because it does tell me to round it to the nearest tenth. So that's going to be about 6.5. Again, I always like to make sure that that makes sense as an answer. That should be my hypotenuse, so it should be bigger than 4.2 and 5, and in fact it is. All right, number 18. Number 18, we have our chord that is getting bisected by this little piece of the 8, and we already have our radius there, 15. The only thing is that when I use Pythagorean theorem on this, it is only going to give me half of the answer. So I'm going to have to double it because we know that that chord gets cut in half. And so I'm going to use Pythagorean theorem. I'm going to say y squared plus 8 squared equals 15 squared. In my calculator, I'm going to type in 15 squared minus 8 squared to get what y squared is. So 15 squared minus 8 squared gives me 161. And so y squared equals 161. I'm going to take the square root of both sides, and y is going to give me a value of about 12.7. I'm going to round at the very end just to be as accurate as possible. It is okay if you do not do that. This is about 12.7. About 12.7. I'm going to go ahead and double the number that's in my calculator because I know that I need to have 2 of those. It's just more accurate that way. So that is going to give me 25.4. X is going to be 25.4 to get x. So times 2. So 25.4. All right, y'all. And then I am so sorry. These directions did not copy where they were supposed to go. Let me copy those onto the next page for our next video. So the directions, sorry, they didn't copy across, but those directions actually follow the problems on the next page. Hope you are having a fabulous day.